let's use the unit circle to find the exact values of the 6 trigonometric functions of any particular angle. And we need to be able to do this with these special angles, these special points around the unit circle, without using the calculator. So I'm going to start off, I'm going to do pi over 4. And what I like to do is I like to write down the 6 trig functions. Sine, cosine, tangent, cosecant, secant, cotangent. I just kind of write them all down. So I'm looking for pi over 4. Well, I see that is right over here. Sine is my y value. So that's pretty easy. Pi over 2, Radical 2 over 2. And cosine is the same thing. Radical 2 over 2. Well, that means tangent, I'm going to do the calculation over here. It's going to be radical 2 over 2 divided by radical 2 over 2. Well, anything divided by itself is 1. So tangent is 1. Cosecant is 1 over sine. So that would be 1 divided by radical 2 over 2. So I need to do a little bit of algebra here. This is the reciprocal, 1 over 2 over 2. So that is equal to 2 over radical 2. And if I need to get rid of my radical 2 on the bottom, I'm going to multiply by radical 2 on the bottom and radical 2 on the top. So that is going to equal 2 radical 2 over 2. And my 2's cancel out. So my cosecant becomes radical 2. How about my secant? Get rid of this here. My secant. Well, secant is 1 over cosine. So 1 over radical 2 over 2. Well, I can see right now I'm going to wind up with the exact same thing that I had for cosecant. So my secant is also going to be radical 2. And then cotangent, well, cotangent is 1 over tangent. But I'm going to encourage you to look at cotangent as a little bit different. If tangent is equal to sine over cosine, then cotangent is equal to cosine over sine. You'll see in another couple problems why that's important. But in this case, it doesn't make any difference. Sine over cosine, cosine over sine. It's both one thing divided by itself, so cotangent is 1. Let's do another problem. 5 pi over 4. Well, first let's find that on my unit circle. 5 pi over 4? Where's 5 pi over 4? Oh, it doesn't seem to be on my unit circle, is it? Oh, yes it is. Here it is right here. 5 pi over 4. Sine, cosine, tangent. Cosecant, secant, cotangent. Well, I can see it's hard to read, I know, but my sine and my cosine are both negative radical 2 over 2, negative radical 2 over 2. That's because 5 pi over 4 is one of my 45-degree angles, and sine and cosine are going to be the same length. Well, tangent is going to be negative radical 2 over 2 divided by negative radical 2 over 2, which is equal to 1. It is not equal to negative 1. It is equal to 1, because I have the negative signs going to cancel each other out. So tangent is equal to 1. And you'll notice that in the quadrant 1, tangent is always going to be positive. And quadrant 3, tangent is always going to be positive. That's because in quadrant 1, sine and cosine are both positive, and in quadrant 3, sine and cosine are both negative. Let's go over to cosecant. Well, from our last problem there just a minute ago, I know that I know that 1 over negative radical 2 over 2 is going to turn out to be radical 2, but it's going to have a negative sign in front of it. So cosecant is going to be negative radical 2, as is secant going to be negative radical 2. And cotangent is going to be the same as tangent in this case, which is negative radical 2 over negative radical 2. My cosine over my sine. So cotangent is also going to be equal to 1. Let's do a little bit more interesting one. How about 3 pi over 2? Sine, cosine, tangent, cosecant, secant, cotangent. Well, can we find 3 pi over 2? Yes, I think we can find 3 pi over 2 right over here. Well, a little bit different here. Sine is my y value, so sine of 3 pi over 2 is negative 1. And cosine of 3 pi over 2 is 0. What about tangent? Well, tangent is sine over cosine. Negative 1 over 0. That causes a big problem. Not really a big problem. We're just going to say the tangent is undefined because we cannot have undefined. Because we cannot have 0 as a denominator. And as you'll see when we graph these, that at that point there, 3 pi over 2, we're going to have an asymptote in the graph. What about cosecant? Cosecant is 1 over sine. Sine is negative 1. So 1 over negative 1. Cosecant is equal to negative 1. What about secant? Secant is 1 over cosine. Uh-oh, 1 over 0. I think we have another problem. Undefined. Well, no, again, not a problem. Undefined. It's just undefined. What about cotangent? Now, cotangent could cause us a little bit of a conceptual problem here. Because I know the tangent was equal to sine over cosine was negative 1 over 0, undefined. Now, if I look at tangent as cosine over sine, which is fine, then it's going to be equal to 0 over negative 1, which is equal to 0. And that actually is, in fact, the answer. It is 0. But sometimes when you're looking at it, I don't want you to get confused on this, you might look at cotangent as being 1 over tangent. Well, that would be 1 over 0. And it can kind of throw us off because we know that this is undefined. Undefined. So how do you divide 1 by an undefined number? And you don't need to know this. Well, it's a good thing to understand conceptually. But if I'm dividing, if a number is undefined, it means that as x gets bigger, that the value approaches infinity. So if I have 1 by a number that is approaching infinity, infinity doesn't really exist as a number. But you can see that as this number here gets bigger and bigger and bigger, the whole number over here is getting smaller and smaller and smaller. Until, if it actually managed to reach infinity, it would be 0. But of course, we can never reach infinity. So what I'm encouraging you here is to think of cotangent. Think of cotangent mainly as cosine over sine, and not so much as 1 over tangent. How about negative 3 pi over 2? Well, again, I want to go negative, so I'm going to go negative pi over 2, 2 pi over 2, 3 pi over 2. So I am to right here. And now, so my coordinates of negative 3 pi over 2 are the same as my coordinates of pi over 2. So sine, cosine, tangent, cosecant, secant, cotangent. Sine is my y value. My y value is positive 1. Cosine is my x value. My x value is 0. Tangent is sine. Tangent is sine over cosine, which is 1 over 0, undefined. Cosecant, 1 over sine, 1 over 1 is 1. Secant, 1 over 0, undefined. Cotangent, cosine over sine, so cotangent, again, from our last problem. Cotangent is cosine over sine, that's equal to 0 over 1, so we're okay with calling cotangent 0. How about 7 pi over 3? Where is 7 pi over 3? I'm going to start at my unit circle. I'm going to go once all the way around, gets me to 6 pi over 3, which is the same as 2 pi. So if I want to go 7 pi over 3, I got to go another pi over 3 to right here. So my coordinates are going to be exactly the same as pi over 3. Okay. Sine, cosine, tangent, cosecant, secant, cotangent. My sine is my y value, radical 3 over 2. My cosine is 1/2. My tangent is equal to sine over cosine. That's equal to radical 3 over 2 divided by 1/2. Well, let's get rid of our denominator by multiplying by the reciprocal. 2 over 1 times 2 over 1. Sorry, this is 2 over 1, not 2 over 2. 2 over 1. That crosses out, and I wind up with 2 radical 3 over 2. My 2's can cross off. I end up with radical 3. So tangent here is equal to radical 3. How about cosecant? Well, cosecant is 1 over sine, so I would have 1 over radical 3 over 2. That's the reciprocal. In other words, I'm multiplying by the reciprocal on the bottom and the reciprocal on the top. So those cross off, and it's equal to 2 over radical 3. Well, I don't want a radical sign in my denominator, so I'm going to multiply by radical 3 over radical 3. This is going to equal 2 radical 3 over 3. And in fact, that is what cosecant is. I can't simplify that anymore. So 2 radical 3 over 3. Whoops. Don't do that. What about secant? Secant is 1 over cosine, so 1 over 1/2. It's a reciprocal, so I flip my 2 upside down by 1/2, and I get 2 over 1, which is equal to 2. So my secant is equal to 2, and my cotangent is 1 over tangent. I don't want to say 1 over tangent. I'm going to say cosine over sine. So cosine over sine is equal to 1/2 over radical 3 over 2. I'll multiply by my reciprocal, 2 over radical 3, 2 over radical 3. This cancels out. This is equal to 2 over 2 radical 3. I can cancel out my 2's, so I have 1 over radical 3. I need to get my radical 3 out from underneath the bottom of that. So I'm going to multiply by radical 3 on the top and the bottom, and I get radical 3 over 3. So my cotangent is radical 3 over 3. The last one that I'm going to do here is negative 7 pi over 6. Sine, cosine, tangent, cosecant, secant, cotangent, negative 7 pi over 6. Well, I'm going to start at the beginning here, and I'm going to go negative 6 pi over 6, which takes me over to pi. And then I want to go 1 more pi over 6 negative. So it is the same coordinate on the unit circle as 5 pi over 6. So my sine is the y value, 1/2. My cosine is the x value, negative radical 3 over 2. My tangent is sine over cosine, so 1/2 divided by negative radical 3 over 2. And be careful you don't mess up with your negative signs. Let's get rid of the denominator. Negative 2 over radical 3. So those cancel out. I get negative 2 over 2 radical 3. My 2's cancel out. So that gives me negative 1 over radical 3. I need to get the radical 3 out from my denominator. I multiply both sides by radical 3, the top and the bottom. I end up with negative radical 3 over 3. So my tangent here is negative radical 3 over 3. What about my cosecant? My cosecant is 1 over sine, 1 over 1/2, multiplied by the reciprocal. That cancels out. It equals 2. Secant. Whoa, I made a mistake. Go back. Okay, here we go. Sorry for all this smartboard mishigash. Okay, my cosecant. Oh, I had it as 2. I already had that. My secant. 1 over negative radical 3 over 2, multiply by the reciprocal, negative 2 over radical 3, negative 2 over radical 3, those cancel out. So I have negative 2 over radical 3, and I need to get rid of the radical 3 in my denominator, so I'm going to multiply both the top and the bottom by radical 3 over radical 3. So that gives me negative 2 radical 3 over 3, and that is my answer. Negative 2 radical 3 over 3 for secant, and then finally on a tangent, on cotangent. Cotangent is going to be cosine over sine. Come back and take a look at my unit circle. My cosine, or I could have looked over here at my chart. My cosine is negative radical 3 over 2 divided by 1/2. Let's multiply by 2 over 1. Make it look right. 2 over 1 on the denominator, 2 over 1 in the numerator. That cancels out. Looking at this, I can see that my 2's are going to cancel out. So my cotangent is going to be negative radical 3. And that's going to go right up here. negative radical 3. And there's the bell.